So you've built a machine learning model. That feels like you've crossed the finish line, right? I mean, you've created this amazing thing that can predict or classify or recommend stuff. But here's the twist we're going to unpack in this explainer. Getting the model built, that's just the starting line. The real, and I mean real challenge, is making sure it can actually survive out there in the wild. Okay, let's dive in.
This really gets to the heart of the matter. Take a look at the code for traditional software. It's clean, it's predictable. You put in some numbers, you get a clear answer back. It's a straight line. Now, look at the machine learning system. It is a completely different beast, isn't it? It's not just code anymore. It's a living, breathing system that's tangled up with data, with the model itself, and with all these constant checks. It's a web of hidden dependencies just waiting to cause problems. And yeah, those hidden dependencies we just saw, that's exactly what makes these ML systems so incredibly fragile. The moment they leave the nice, safe, controlled environment of a data scientist's laptop and get thrown into the messy real world, well, that's when things start to break. This is where good models, unfortunately, often go to die.
So you've got these three huge challenges that you just don't run into with normal software. First, the whole system lives and dies by the data it's fed. Garbage in, garbage out, literally. Second, its performance just naturally fades over time as the world changes. You know, a recommendation engine that's genius today could be totally clueless in a month, and that costs real money. And finally, just trying to get the same result twice, it's surprisingly difficult. This is not a set it and forget it kind of deal, not even close.
And this is a perfect story of what we call model decay. It isn't some big, loud explosion. Nope. It's a slow, quiet fade into uselessness. On day 1, the team is high-fiving, celebrating their success, but by day 30, maybe user behavior has shifted just a little, and accuracy takes a hit. By day 60, seasonal trends kick in and it gets even worse. Then, boom, day 90, the system sees something brand new, like a new product category it was never trained on, and it doesn't just get it wrong, it completely crashes.
Okay, this all sounds pretty scary, right? I mean, if these incredible systems are built on such shaky ground, how does anyone actually get them to work long-term and provide real value? How in the world do we build them to last? Well, the answer has a name, MLOps, and it's not some magic tool you can just buy. It's a discipline, a set of practices that smashes together 3 different worlds: the creative experimentation of machine learning, the rock-solid automation of DevOps, and the careful precision of data engineering. Its entire reason for existing is to solve the exact problems we've been talking about. So let's get into the blueprint for how this all actually works. MLOps is really built on 4 core principles that are designed to turn machine learning from a cool science experiment into a reliable, trustworthy system you can actually depend on. First up, you have to version everything. And I don't just mean the code. I mean the data you used for training and the model file itself, every single piece. Think of it like a time machine for your entire project. If a new model goes haywire in production, you can instantly see what changed, and more importantly, roll back to a previous version that you know worked perfectly. It's the ultimate safety net. Principle number 2, automate everything. Seriously, the best analogy is a factory assembly line. You wouldn't want someone building each car by hand, right? You'd have mistakes, inconsistencies. It'd be a mess. You want a smooth, repeatable, automated process. It's the exact same idea for ML. Automating data checks, model training, and deployment takes human error out of the equation and gives you consistency every single time. Third, and this is huge, you have to monitor everything. This is basically a 24/7 health check for your model out in the real world. You're asking, is the system running fast enough? Does the new data coming in look weird? And maybe the most important question of all, is this model still doing the job we built it for? Monitoring is how you catch that slow, silent decay we saw earlier, before it turns into a full-blown crash. And finally, the 4th principle is all about the people. It's about collaboration. See, MLOps is also a cultural shift. It's about tearing down that wall that often exists between the data scientists who invent the models and the engineers who have to keep them running. Everybody has to be on the same team, communicating and working together from day 1.
Okay, so we've got the principles down, but what does that journey actually look like for a company? How do you go from total chaos to a smooth, automated system?
Well, it usually happens in stages. Most people start at level 0, which is basically the Wild West. Everything is done by hand, and deploying a new model is a huge, scary event that rarely happens. The next step up is level 1, where you start to automate the training part of the process. But the real goal, the holy grail, is level 2, full CI/CD automation. CI/CD just stands for continuous integration and continuous deployment, which is a fancy way of saying the entire system is automated. New models can be tested, validated, and released quickly, and most importantly, safely.
But of course, you can have the best tools and the most automation in the world, and it won't matter one bit if you don't have the right people. This stuff absolutely takes a team.
And this is what that dream team looks like. You've got the data scientist who's exploring the data and building the core model. Then the ML engineer comes in to turn that experimental model into a tough production-grade system. The data engineer makes sure all the data feeding into it is clean and reliable, and the DevOps engineer builds and manages all the infrastructure that everything runs on. Each person has their specialty, but they are all completely dependent on each other to succeed.
So look, if you take just one thing away from this whole explainer, let it be this. MLOps is not a piece of software you can just go out and buy. It's a culture. It's a disciplined, systematic, and collaborative way of working that's absolutely necessary if you want to turn a promising ML experiment into a real product that delivers real, lasting value. Which kind of leaves us with one final big question to think about. As our AI models get more and more powerful, maybe the biggest challenge isn't just building a smarter model. Maybe the real test, the thing that will define the next decade, is proving that we can actually trust these systems when they're out there making decisions in our messy, unpredictable world.